Thank you. Hello everyone, I'm Arindam from the University of South Australia's Empathy Computing Laboratory. So in our lab, we are focusing on making computer interfaces more empathetic. In particular, we are focusing on collaborative augmented and virtual reality environments. We are interested into look at how we can make collaborators understand each other more in terms of their emotions. If you think of real-world communication or collaboration, when you are co-located with your collaborator or the person you're speaking with, there are subtle communication cues that communicate the emotion of the other person, but those things are missing when you collaborate over a computer or remotely, particularly in the context of augmented and virtual realities. So this is the gap we are trying to bridge through our research. So for the current work that I'm presenting, I'm trying to present the work that we did using the collaborative virtual reality game. So the main motivation that we had was how we can make virtual reality interfaces and collaborations more empathetic by measuring and sharing physiological cue between the collaborators. There have been some earlier work in this direction. I will not go into details about each of them, but collectively, we found out that the VR can trigger emotional responses quite accurately. And we also found that heart rate and other physiological measures can be a good indicator of human emotions. And in context of a video conferencing setup, we found that by sharing physiological cues, we can increase the positive effect between the collaborators. However, most of these tasks were single-user experiences, and we are basically more focused on the collaborative interfaces. So the contribution that we have is for the first time, we are presenting a collaborative virtual reality game where we are sharing a physiological cue between two collaborators in real time. And we are also presenting an evaluation of that interface. So to test the effect of sharing the physiological cues, we designed a mixed factorial user study where a physiological cue was the between subject variable, where one group experienced that physiological cue and another group didn't. As you can see on the right-hand side of the picture. We also created two different kinds of gaming experiences. One was a bit more joyous and calm game of collecting butterflies in an open field, and another one was a more scary experience where people were placed within a dark warehouse where they had to kill zombies to survive in the environment, and that was a within subjects variable. So the experimental setup that we had, I'd like to point out one very important thing here, because we are interested more into finding out how the other person can feel the effect of one's emotion. So we always, the participant was always an observer, so they didn't have any control to play the game, but they could experience the game as played by the player, and the player in that case was an experimenter, and I was the experimenter in all of these cases to keep it consistent for all the participants. And although they were co-located in the virtual environment, they had a different, they were allowed to have different head orientation, which enabled to decrease the dizziness and also to enable higher presence in the environment. And I will show you a video where you'll see these things, our setup and the games in action now.
In this research, we explore the effects of sharing physiological states of players in collaborative virtual reality gameplay. Our goal is to improve and enhance users' empathy among collaborators, especially in a remote setting using advanced computer interfaces. To support this study, we developed a collaborative VR framework which shares the player's position and heart rate to the observer in a virtual environment. The observers view the game from the player's position, but can rotate their head freely to look around. The player's heart rate is measured by a biometric glove. The measured heart rate is shared with the observer using both visual and audio cues. We developed two games based on this framework. The first game provides a calm and pleasing experience where the player catches butterflies while surrounded by nature. The second game presents a scary and stressful situation where the player tries to survive zombie attacks.
Right, so here we explicitly mentioned to the participants that the heart rate they're seeing is of the player. And we also told them that they can, if they wish to, they can communicate with the player to assist them in the gameplay. So the data we collected, both subjective and objective data. In terms of subjective data, we collected positive and negative affect schedule, which is basically a set of 20 emotions and feelings grouped into positive and negative. And we also had a subjective questionnaire. In terms of objective data, we collected the raw heart rate of the player and also the relative head orientation. The relative head orientation was basically the horizontal angle between the player's view direction and the observer's view direction. And we collected that at every frame. So overall, we had 26 participants, 13 in each group, and there were 7 female participants in our study. We hypothesized that when we show the heart rate feedback to the participants, so the participants will feel more connected to the player, and it will generate more positive effect, and also it will generate more communication between the participant and the player. And also for the zombie game, we expect when we show the zombie game, it will trigger higher subjective and understanding of the emotions, and also it will trigger higher attention to the game. So for the results, we first present the raw heart rate. We collected heart rate at 3 different points, first at the baseline and then during the 2 gaming sessions. We found that there was an increase in heart rate when players were actually playing the game, which is understandable because they were moving and they were standing. But we didn't find any effect of the physiological cue or the game, although there was slightly higher but non-significant heart rate in terms of in the case of the zombie game. Now, for the positive and negative affect schedule, we found a significant effect of the gaming experience, and where the scary game created both positive and negative effects. Now, if you look at the graph more carefully, you will see that the blue bars, which represent the physiological cue on condition, it always, in both of the games, it created higher positive effect, although it was not the case for the negative effect. So it showed a promise that it could be that there was an effect of the heart rate, but with the number of participants we had, the effect was not significant. Similarly, when we asked them the subjective questions, here I need to say in these graphs that you are seeing, these are on the reverse scale, so the lower values indicate better results. And we found that when we asked about the understanding of the emotion between the player and the participants, so participants said that they, in the case of the scary game, they felt they understood the emotional state of the player more, and they also had more attention. They had paid more attention to the game. We didn't find any significant difference in terms of the enjoyment of the collaboration. Again, if you look at the graphs here, you will see that the heart rate on condition always had better results. But again, it was not significant with the number of participants we had. In terms of head orientation, we found a significant effect of gaming experience, where in the scary game, the head orientation was more diverse than the scum butterfly catching game. Now, the reason being, when you asked the participants, we found out that during the butterfly catching game, there was always a stick with the net. So participants assumed that the player's gaze direction was aligned to the stick, and which was the case in most cases, and that's why they had a cue to align their view to the player's view. However, that was not the case in case of the zombie game, because in that case we had a flashlight and a gun, but it was not always in the view because I was not always shooting like this. So they didn't find that cue. And at the same time, because it was a zombie game, they were attacked by the zombies. They tried to find out where the zombies are coming from. So we experienced a different kind of effect here. So overall in the study, we found that there's only one of our hypotheses were accepted, that the game had a significant effect on the understanding of the emotions. However, we found a very encouraging effect that the heart rate, showing the heart rate sensor, showing the heart rate data really increased their performance and also their positive effect. However, we didn't find the effect to be significant due to the limitation that we had only 13 participants in each group. There were some other limitations in our study. First, the heart rate data that we recorded was using an Arduino sensor, and it was not as accurate as medical grade devices, particularly when there was a lot of hand movements involved. Also, we only recorded the heart rate, but there are many other physiological cues, such as GSR or the respiration, and then there are other cues such as facial expression, which we didn't record, so that is also another limitation. And also only 2 experiences were evaluated here. One was joyous, and another one was scary. But there are many other experiences in between, and also we just used a gaming experience here, but there are other VR experiences beyond gaming. So we need to explore these things later on. So for the future research, when I interviewed the participants, we found quite a few observations that will direct us to some future research directions. For example, the gaze direction feedback should be given to the player and the participant. And the reason being, participants said that because they didn't know where the player was looking, they couldn't really communicate effectively, because if they wanted to speak in a way that turn to your left or turn to your right or turn to your back, but they didn't know where the player was actually looking at, so they couldn't really communicate well. So we need to include that in our future gaming interfaces. Also for the voice communication, although we told the participants that they can freely talk to the players, but they didn't choose to do so in most cases. And the reason being, they thought that because the player had the headphone on, they thought that the player couldn't really hear. So we think if we explicitly, if we make it more explicit by adding, let's say, a mic to the interface and tell them that you can speak through the mic and participant and the player can hear, that will probably increase the voice communication between the collaborators. And we also need to find out salient ways of visualizing the physiological cue. In our case, as you have seen in the video, the heart rate was shown on the bottom middle of the screen. When we interviewed the participants, they said that, okay, we knew that it was there, but we didn't pay attention to it. We are more interested in the game, which is fine. We don't really want to be too obtrusive. But for example, when the experience of the player is something significant, for example, when he gets really agitated or stressed, in those cases, it is important that the observer understands that what is going through with the player. So in those cases, we need to find a way to make it more salient so that people or the observers really notice it. Also need to we need to add more interaction for the observer, otherwise it becomes a bit boring for them. And we need to explore other physiological cues, and also we need to continue the study with more participants, because we found a really encouraging sign of sharing the physiological cues being effective, but it was not significant, so we want to explore that further by adding more participants in our study. So in summary, I presented the first of its kind virtual reality interface where heart rate information was shared between the players, and here in that case, player inhibited the same body but had different head orientation, which decreased the dizziness and increased presence. Heart rate showed strong promises, and we would really we know that we are in the right direction and we need to explore further and to create this kind of interfaces more empathetic. And the scary game had showed more positive and negative effect, and also it created more subjective understanding and the attention during the gameplay. Now, before I finish, I'd like to say that ours is a new lab, and we are looking for new PhD students. So if you think you are or someone you know would be interested to pursue a PhD with us, please feel free to pass this information to them or contact me directly. Thank you very much.
Sultan Harti, New Mexico State University, Pixel Lab. Great work. I was wondering if you thought about maybe incorporating these physiological cues into the gameplay itself. For example, making the collaborator try to reduce or increase these heart rate, for example, in a mindfulness settings or in an exertion game. This will make the collaboration more robust. Did you think about this, or how this will change the results?
Well, we didn't really. So what we try to do here is to find out the effect of of this kind of visualizations on the collaborator. But we haven't really pursued that direction yet. What you are saying, but it will be interesting to go into that direction. And the next thing we want to do is, when we know that someone is getting excited or getting stressed, how we can basically calm them down. So this is one of the ways that we want to pursue further.
So I have one question. So I think in the research, like you try to combine between the visual cues and the, well, how can I say, like integrate like more than one cues, like visual cues from the hard animations and the sounds.
Yeah.
Right. So how's about like if you consider like in the separate case, like you consider only sounds and only visual, so it might be like files like more clues that what is the impact to the sharings of the feelings or something like
Yes,
that.
that's a very good question, and you have basically said what we have already done a study about it, which we'll submit very soon. So where we have basically tried to find out how we can visualize these things more effectively. For example, here we have the only audio and visual cue. We have also added the haptic cue using the Vive controllers, where the heartbeat basically is, the vibrator vibrates with the heartbeat, and we are trying to factor out the effects of each individual cases, how effective it is or not. So
I see. Like also the size of the hard animations, I think is like if you can find like the optimal size or whatever, or the positions, or changing the visual cues, like make the red color instead of the animations of the heartbeat, maybe might be more effective to the.
could be, yeah. But basically, this is the first work that we did in our lab, and we tried to find out similar work, but we couldn't find any. So there are lots of things we need to explore. So so we are doing that. Thank you.
Okay. So let's thank you for the speaker again.